Welcome to this video on the history of Indian geography for Class 6 students, based on the new Maharashtra State Board syllabus. In this section, we complete a table linking Indian festivals to specific months and their geographic significance. For example, Makar Sankrant in January relates to post-winter harvests, rising temperatures, and lengthening days. Continuing with our table, we see Gudi Padva in March, marking the Hindu New Year and the start of spring. We also look at Diwali, observed in October or November, celebrating the harvest and victory of good over evil. Christmas in December is noted for severe winter and the year's shortest days. Additionally, we note that the beginning of the month for Ramazan Eid varies according to the lunar calendar, with observance tied to latitude and season. This concept map illustrates the ancient dweepas or islands, including Kumari, Plaksha, Shalmali, Kusha, Krancha, Shaka, and Pushkara. Here, we explore ancient geographic concepts, mapping terms like Brahman to the universe, Bharatvarsh to Jambudweep, and traditional measurements for time and space. Let's complete these sentences. The majority of Jambudweep lies in the Asia continent. The area of lotus-filled lakes is part of Pushkar Dweepa, and during a lunar eclipse, the Earth's shadow falls on the moon. In this exercise, we identify the odd element. Jambudweep is the outlier in the first group, while Chandrayaan is the odd element among the celestial terms listed. Testing our knowledge with Identify Who I Am. The land with abundant jamun trees is identified as Lakshadweep, while the area associated with Kranch Mountain is Jambudweep. Continuing our identifiers, the land of Kushgrass is Kushadweep, and the land surrounded by water is Pushkardweep. Writing a short note on the universe, it encompasses everything that exists, including space, time, stars, planets, galaxies, and all matter and energy. On the Earth, it is our home planet, the third from the Sun, and currently the only one known to support life. Regarding a dweep, this refers to a small island that is surrounded by water on all sides. Finally, an eclipse occurs when one celestial body moves into the shadow of another, effectively blocking its light. To wrap up, use a calendar to complete this seasonal cycle diagram by filling in the appropriate names of seasons, months, and festivals in the provided spaces. Now, let's explore the contributions of ancient Indian thinkers to science. First is Aryabhata, born in 476 CE, a famous mathematician and astronomer who wrote the Aryabhatya. He scientifically studied eclipses and explained that the Earth rotates on its axis. Next is Varahamihira, who lived from 505 to 587 CE. He was a great geographer and astronomer. His work, the Brihat Samhita, covers a wide range of topics, including weather patterns, rainfall, astronomy, and geography. Moving to the 6th and 7th centuries, we have Brahmagupta. He was a distinguished mathematician and astronomer, credited with developing important rules for zero and negative numbers, as well as advancing the study of planetary and stellar movements. Finally, we recognize Bhaskaracharya, or Bhaskara II, who lived in the 12th century. He authored the Siddhanta Shiromani and made significant discoveries in mathematics while providing detailed explanations of planetary motion. In conclusion, these ancient Indian thinkers laid the foundation for modern scientific knowledge. Their observations of the Earth, seasons, and heavens helped shape early understandings of geography, mathematics, and astronomy. This final diagram summarizes the various ancient concepts we have discussed, helping to visualize the connections between early Indian thought and the natural world. We will now examine travelers who documented their experiences in India. First is Megasthenes from Greece, who visited during the reign of Chandragupta Maurya and wrote the historical account known as Indica. Next, we look at F. Ayen from China. He traveled to India during the Gupta period, providing valuable descriptions of Indian society and the practice of Buddhism at that time. We also have Huan Sang, another Chinese scholar who visited India during the reign of Harshavardhana. He recorded extensive information regarding Indian education, culture, and geography. Finally, we note the contribution of Aitsing, also from China. He came to India primarily to study Buddhism and documented details about the education system and local monasteries. This concluding image provides a visual representation of historical travel and the exchange of knowledge between ancient India and other civilizations. We now turn to the legacy of Brahmagupta, who lived between 598 and 668 CE. A renowned mathematician and astronomer, he is famously known for developing the fundamental rules for zero and negative numbers. Beyond his mathematical contributions, Brahmagupta also dedicated his studies to the movement of planets and stars, providing early insights into celestial mechanics. Next is Bhaskaracharya, also known as Bhaskara II, a prominent figure of the 12th century. He was a brilliant mathematician and astronomer who authored the influential text Siddhanta Shiromani. Bhaskaracharya's work offered deep insights into planetary motion and included significant breakthroughs in mathematics, further advancing the scientific knowledge of his time. In conclusion, ancient Indian thinkers made remarkable contributions to geography, astronomy, and mathematics. Their systematic observations of the Earth, stars, and seasons helped build the foundation for modern scientific understanding. This image illustrates the rich historical context of the various scholars and thinkers we have discussed, symbolizing the depth of ancient Indian scientific inquiry. This final slide displays summary answers for our review, including the historical accounts of travelers like Megasthenes, F. Ahien, Huenzang, and Ai Tsing, which help us understand ancient India through their eyes.